Okay, so today we're going to learn how to balance chemical equations. So I've started us off with this practice equation. Silver nitrate plus copper is going to give us copper nitrate plus silver. And so I've kind of rewritten this equation with these blanks in here so we can fill in the coefficient blanks. So I'm going to start by listing out exactly which reactants and products I have, which elements are found in those reactants and products. So first off, I notice that I have silver on both sides. I also have copper on both sides. And I have nitrate on both sides. So this is one of those points where we need to know our polyatomic ions. One thing I like to do with my polyatomic ions, you see it on this right-hand side, NO3, it's in parentheses. So I'm going to do that over here on the left-hand side. Put my NO3 in parentheses. That will help me make sure I know that that is one thing. It's not a bunch of different ions. It's one polyatomic ion that doesn't break up, it stays together. And we call that the nitrate ion. So looking at my silver on the reactant side, how many silver ions do I have? Well, it has no coefficient here, subscript here. So I know that there's only one. So I'll fill in a 1 right there. On the right-hand side, I do the same thing. Look at silver, see what the subscript is. There's nothing there, so that's an implied 1. Next, we're going to look at copper. So copper on the left-hand side, again, there's no subscript right there, so that is an implied 1. Same thing on the right-hand side, there's no subscript right beside the copper symbol, so that is also an implied 1. So now we'll look at the nitrate ion. I'm going to look here beside this nitrate ion, there's no subscript there, so remember that's an implied 1. And on the right-hand side, we look at the subscript after the nitrate ion, outside the parentheses, that is a 2, so there's a 2 here. So, quick check, is this equation balanced? Well, it's a balance for silver, it's balanced for copper, those two numbers are the same, but for nitrate, is that balanced? I have a 1 on the left-hand side and a 2 on the right-hand side. This is not balanced. So now I need to fix that. How can I fix that? So what I can do, I need to make this 1 become a 2. So I will need to put a 2 in front of the substance that has a nitrate ion in it. And that is going to be our silver nitrate substance. So now that I will update my chart. How many silver do I have on both sides? I have 2 silver here now. I've got 2 times 1 gives me 2 silver on the left-hand side. On the right-hand side, I still only have 1 though. We'll come back to that in a second. Copper, I have 1 copper here and 1 copper there. So that stays the same. And now nitrate. How many nitrates do I have on the left-hand side? 2 times the implied 1 gives me a 2 now. So I have to update that. So now let's check. Is it balanced? It is not balanced for silver. Is it balanced for copper? Yes. Is it balanced for nitrate? Yes, now it is. We've fixed that. So now I need to look and see, what do I need to do to balance silver? I've got 2 silver on this side. On the right-hand side, I only have 1. So I need to put a 2 here to make sure that I have 2 silvers on both sides. Now that I've done that, I can update my number. Now I have 2 silvers on each side. And guess what? Now the whole reaction is balanced. So one last thing here, we don't want to leave these blank spaces as blanks. We want to either fill them in with a 1, but we do not want to fill them with a 0. There is a copper atom there. We do not want to fill that in with a 0. We want to make sure we fill those in with 1s, right? So let's go to our next step. We're going to look at a redox reaction and try to balance it. So I've taken my balanced chemical reaction from the previous step, and now I'm going to examine that with a redox analysis. So again, remember, you have to start with a balanced chemical reaction in order to do a redox analysis on it. We're going to start same way we did with on the previous slide where we wrote in our elements. We'll do the same thing in the redox chart that we're going to create. I have a silver ion, I have a copper ion, and I have a nitrate ion. And using this chart, we're going to figure out which one is oxidized and which one is reduced. First thing I'm going to do, what is the charge for each element or ion on the reactant side? So I look up here, let's see, my polyatomic ion nitrate, what is its charge? Well, I need to remember that a polyatomic ion nitrate has a -1 charge. So I'm going to fill that one in. I'm going to do that one first because that's one I should have memorized. I should know that one. Silver, it could have different oxidation states. It could have a different charge than that. So we're going to start with the things we know that aren't going to change. So if nitrate is -1, to make this a neutral compound altogether, silver must be +1. The charges have to cancel out so that we have a neutral compound. Okay? And that leaves me just with copper. What is copper's charge? Well, I look up here. This is an element. It is not an ion. It's not bonded to anything else. So I know that its oxidation state must be 0. So we're going to fill in here that copper's oxidation state is 0. That's the charge that it has on the left-hand side. Now we're going to go to the right-hand side. Nitrate, we'll start there again. Did it change? Is it going to change? Well, it's still bonded, but this time it's bonded to copper, so its oxidation state's not going to change. It's one of those things we have memorized. On the right-hand side, we see that silver is by itself. It is not bonded. That means it has a charge of 0. And then lastly, copper. What is its charge here? Well, if nitrate is -1, each nitrate's a -1, but there are 2 of them, this whole thing must have a -2 charge. So to cancel that out and make it 0, copper must have a +2 charge. So we can write a +2 here. Now, let's start at nitrate again. Nitrate, did its charge change? No, it did not. So that means it was neither oxidized nor reduced. So I'm just going to put a dash here, saying that it did not change. Silver, did its charge go up or down? Remember, Leo says grr. If we lose electrons, we are oxidized. Losing electrons means that your charge went up. You lost a negative, means you gained a positive. So if the charge went up, then it's going to be oxidized. But if the charge went down, if you gain an electron, you gain a negative, you're going to be reduced. So what happened? Silver, did it go up or down? It went down. 1 is greater than 0. It went down. That is reduced. Copper. What happened to copper? Well, its charge went from 0 to +2. It must have lost some electrons. That means it was oxidized. The charge went up. Okay? So now this is very important. We need to use our coefficients. Some of them are implied. And our charges to write our half reactions for each of these. So I'm going to start with my reduction half reaction. Which one got reduced? Silver got reduced, right? Silver got reduced. So we'll go back and look at our equation and figure out what coefficients does silver have on each side. Well, silver on the left-hand side had a 2, but its charge was +1. So I'll write 2 silver with a +1 charge. That's on my left-hand side, and then on my right-hand side, I'll leave some space. On my right-hand side, what happened to silver? Silver had a coefficient of 2, but its charge was 0. So on the right-hand side, I'll write 2 silver. And you can even write this 0 in here if you want to. It's not required, it's kind of implied, but we can write that in if you want. So now, I've got my reduction half reaction almost complete. Last thing I need to do is add electrons. So, which side has a higher charge? And what is that charge? So on the left, I have 2 silver atoms, each with a +1 charge. That means it must be +2 overall. It must have a +2 charge overall. On the right-hand side, I have 2 silver atoms, but they're both neutral. So this one's total charge is 0. So I need to add electrons somewhere to make these equal. Remember, electrons bring the number down. So I'm going to add electrons to the side with a higher total charge. I'm going to add 2 electrons here. What is the total charge of 2 electrons? This is -2. So now we see that this +2 charge from the silver minus 2 charges from the 2 negative electrons, that's going to be equal to my 0 on the right-hand side, my neutral silver atoms. So now this reaction is balanced by charge. Now let's do the same thing for our oxidation reaction. Let's go back. Which one got oxidized? Copper got oxidized. So we'll go here and write what was copper to begin with. It had coefficient of 1. So I have 1 copper. You can write this 1 in here if you want. You don't have to, but sometimes it's helpful to remember that. Go back to the right-hand side. How many coppers did I have? I still only had 1 copper on the right-hand side. But let's look at the charges now. What was the charge of copper on the left? On the left it was 0, on the right it was +2. So now I'm going to fill those in. 0 and +2. How can we make these charges balanced? So we're going to look on the left-hand side. What's this total charge? It's a total charge of 0. I have 1 copper with 0. It's a total charge of 0. On the right-hand side, what's the total charge? I have 1 copper that has +2 charge. Total charge is +2. So now, where do I need to add electrons to make this balance out? Well, I've got to add electrons to the side that's higher to bring the total charge down. And I have a +2 on the right-hand side. That tells me I need to add 2 electrons on the right-hand side to cancel those 2 out. So now I have 0 is equal to +2 minus 2. That is now balanced. All right. So now we have successfully written our 2 half reactions